Okay, geometry folks. We're going to look at just some of the basics of angles here, and what I really want to emphasize in this video is just kind of what do we even mean when we talk about an angle? What is that? How can we think of it? How is it represented? Sort of thing. And so what we're not actually going to probably do a lot, but just to help you understand, is that we can think of an angle as a rotation around a circle. So I've got a couple circles drawn here, and we can think about, we would pick one of these two circles, doesn't matter, the bigger one, the smaller one. We can say, okay, if we start somewhere on the circle, maybe we start at point B, and then if we go around the circle, how far have we gone? So if I'm looking here, if I start at point B, and I want to get to point D, so I rotate around this smaller circle, I've got a certain angle. What if I go to the bigger circle and I start here at point A and then I rotate to point E? I've rotated a certain number of degrees around that bigger circle. But looking here for this example, so I just broke down these angles that we have. I wrote down angle DCB has sides CD and CB and vertex C. So if you know the parts of your angles, an angle has two sides and one vertex. And if I want to find angle DCB on here, if you remember, I can trace this, and I can start with point D and locate that, and then go, what's next is C, so follow C, and then go to B. So right here, this is the angle, what I just traced in green here. I just created angle DCB, or rather I traced that angle DCB. And when I drew here from B rotating to D, that's exactly the angle we're talking about. Okay, so we've got our one side right here, here's side CD, here's side CB, and then here's the vertex C. If I look at angle ECA with side CE and CA and vertex C, again, if I want to trace that out, I could start at E and then go to C and then go to A, and now I have traced out kind of that angle ECA. And then we have our sides, CE is one side here and CA is the other side, and then we've got vertex C. So again, that was on this bigger circle what I had done originally. If I start at point A on the big circle and then I rotate to point E, I am basically rotating the same as the measure of angle ECA. But the thing I really want to emphasize here, and I'll circle this in red, is that these two angles that we're talking about here, angle DCB and angle ECA, they have the same measurement. They have the same measure. I don't know what that is here. I could estimate it. I say, oh, it looks like maybe it's 40, 45, 50 degrees, something like that. But they have the same measure. Even though going from B to D is shorter than going from A to E, that's talking about distance. When we talk about, again, the rotation around the circle, okay? If we go all the way around the circle, doesn't matter if it's the big circle or the small circle. If we go all the way around the circle, we know that is 360 degrees. That's all the way around the circle. 360 degrees. So it doesn't matter the size of the circle. If you rotate all the way around, again, you would have traveled further going around from A, going all the way around back to A, than you would have if you started on the smaller circle, starting at B, going all the way around to back to B. But your degrees, your rotation that we're measuring is the same, 360 degrees. So these two angles, because CE is just an extension of CD. If I go from C to D, and then I go, but wait, let's keep going, I'll get to E eventually. So these two sides, CD and CE, are really the same side, and likewise CB and CA are really the same side, because if I go from C to B, but then I just extend it and I keep going to A. So these are really the same angle, they have the same measure. And then the last thing I'm going to do here is I'm going to try and convince you of that. So here I am, I'm on some dynamic geometry software called Geometry Sketchpad, and what I'm going to do here is I'm going to think of this as my angle as opening like a door maybe. So the hinge is going to be at point C, and then I'm going to open the door, and however far I want to open the door. It doesn't matter if I follow a point towards the outside of the door or kind of in the middle of the door. E is more to the outside of the door. D is more in the middle of the door. They're both part of the door. So as I'm opening this, these two angles that were talked about, DCB and ECA, they're going to be the same. They are the same angle. And what I can do on this software is I can have the computer measure those angles for me, and then we can see what happens here. Okay, so here we go. So I've asked the computer program to measure the angles. So we've got the measure. The M, by the way, stands for measure of angle DCB. Right now it's got it at 25.12 degrees. ECA is exactly the same, 25.12 degrees. So if I click and I drag this point, notice that the angles are changing. I'm opening the door further, so the angle is changing, but the two angles are always exactly the same. Okay, so I could say, hey, let's open the door all the way, and there we go to about 180 degrees. There's 180 degrees. And then if I could swing the door open further, I'd get the reflex angle, but now the program is taking the non-reflex angle. So it's not showing over 180 degrees, but the angles are still the same, whatever they are. Now it's 26.83 degrees for both of them. So I just want to show you that, give you that basic idea of an angle. It has nothing to do with the size of the sides. It's all about how far are you rotating around a circle. What fraction of the 360 degrees are you rotating around the circle. So we'll keep working with this as the term goes on. But keep that in mind, sides are different from angles, angles are different from sides.